We're going to look at the important features of a quadratic function or a parabola. The graph of a quadratic function is always going to be a parabola, this kind of shape that you see here. Sometimes it's open down. We'll look at a couple of examples that are open up, but all of what we say would apply in those other cases as well. You might recall when we studied linear functions that the important features of a linear function are the y-intercept, the x-intercept, and the slope. In the case of quadratic functions, again, we will often be interested in knowing the y-intercept and the x-intercept. In this case, there are often two x-intercepts. But we can't talk about the slope in the case of a parabola so easily because the slope is constantly changing. So it's a negative slope on this part of the graph, and it becomes less negative. It's briefly equal to 0, and then the slope becomes positive. But again, it's not just a single number like it would be in the case of a line. It's getting steeper and steeper. And so calculus methods could be used to find a formula that would give us the slope of this graph at any particular point. We're not going to get into that so much, but we will be interested in knowing where is this turning point. It's called the vertex, where the slope is briefly equal to 0 and then changes to being in the other direction. So it turns out that we will be able to find a fairly simple formula that will allow us to identify where that turning point is, and in many of our practical applications that we're looking at, that will be an important point to be able to find. It will be able to help us answer some questions. So back to the y-intercept. The y-intercept is found by substituting 0 for x. That means we'll be finding a point right on the y-axis. And it is generally very straightforward. So if we substitute in 0 in this first example, we get y equals 0, and we can see on the graph that the point 0, 0 is in fact the y-intercept. We have a second example here. Y equals x squared minus 4x plus 3. If I substitute 0 for x here, I get y equals 3. And we can see on the graph our y-intercept is 3. And one final example here. If I substitute 0 in this equation, I get y equals negative 2. And again, you can see that that's the y-intercept. The x-intercepts take a little bit more effort because they're found, of course, when we substitute 0 for y, but then that gives us an equation that has a squared term and often an x term as well. So we know that our strategies for finding the solutions to an equation like this are a little more involved. Frequently we will factor. Other times we will need to use the quadratic formula. So just to review both of those quickly here, this one we can factor quite easily. Remember, before we factor, we always have to have 0 equal to the rest of the terms. So we have that here. So we're ready to factor. Now the importance of having 0 then is because we can say, oh, I have a product now that equals 0. So that's going to only happen if one of my factors equals 0. So I can look at each factor separately and say the solutions to my equation are either x equals 0 or x plus 2 equals 0. Of course, if x plus 2 equals 0, that means x equals negative 2. So those are the two solutions to my equation. Remember, we were finding the x-intercepts, and so going back to the graph, I can see, in fact, those are exactly the x-intercepts. So here at x equals negative 2, x equals is where the function crosses the x-axis. In the second example, we have y equals x squared minus 4x plus 3. If we're looking for the x-intercepts here, we'd substitute 0 for y. And just suppose this time that we didn't see immediately how to factor and that we decided that we would use the quadratic formula. Remember that the quadratic formula says if 0 is equal to ax squared plus bx plus c, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure that you have that memorized. So in our example, our a, the coefficient of x squared, is equal to 1, b is equal to negative 4, and c is equal to 3. So we substitute those values, and we get negative b, the opposite of negative 4, is a positive 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 3 over 2 times 1. This is 4 plus or minus the portion under the radical. 16 minus 12 is 4, so plus or minus the square root of 4 over 2. Oops, let's push up a little. See if I can make this easier to follow along. Okay, so of course this is rational, so we get either 4 plus 2 over 2 or 4 minus 2 over 2, and those simplify to 3 and 1. So those are the two solutions that I get to my quadratic equation. And again, remember we were looking for x-intercepts, so let's confirm. X equals 1, x equals 3. These are the x-intercepts. In our third example, we have a little bit of less work to do. When we substitute 0 for y this time, we see there's no x term, and so I can kind of shortcut my procedure here by just saying, well, this means that 2 equals x squared, and I can take the square root of both sides. Just remember that you need to get both square roots, so plus or minus the square root of 2 would be the solutions for x. And the square root of 2 is approximately 1.4, so that's where to look on our graph. And in fact, that looks pretty much like what we've got here. So positive square root of 2, negative square root of 2 would be the solutions, which are the x-intercepts to this graph. Okay, finally, let's consider that turning point. The nice thing about parabolas is that they have symmetry. Okay, if we imagine putting a vertical line right through the turning point, the left side and the right side are just mirror images of each other. So that means that if I know where the x-intercepts are, that I can find the turning point by just looking in the middle. Midway between those x-intercepts is always going to be the turning point. See, this happens here between negative 2 and 0. Halfway between is negative 1. That's where the turning point is. And in my other examples, here I had x-intercepts of 1 and 3. Halfway between is x equals 2, the turning point. And finally here, positive square root of 2, negative square root of 2, halfway between would be 0. So finding the x-coordinate of the turning point is actually not difficult if we have our x-intercepts. Now, of course, there's those cases where we have just one x-intercept, and then it turns out that the x-intercept is the turning point. Or if there are no x-intercepts, well, we might be a little bit stuck, except that we can think of this another way. We can compare that formula, the quadratic formula that we use to find the x-intercepts. We can compare that and use it to help us find the x-coordinate of the turning point if we rewrite it a kind of a clever way. So we know that the quadratic formula that allowed us to find our x-intercepts is this: negative b plus or minus the square root of b squared minus 4ac over 2a. Let's break that into two fractions. That means the first part is negative b over 2a, and then plus or minus b squared minus 4ac over 2a. Okay, so the two x-intercepts are some number plus something and minus that same thing. Let's think about how that maybe is related to the x-intercepts and the turning point. The turning point is in the middle here, right? This turning point was x equals negative 1, and if you add 1, you get one intercept. If you subtract 1, you get the other intercept. Okay, so Same thing with our second example. Pull it out here so you can just compare. My turning point was here at x equals 2. If I add 1, I get one intercept at 3. If I subtract 1, I get the other intercept at 1 rather. Okay. Just coincidence that we happen to be adding and subtracting 1 in both cases there. Remember our third example, we a square root of 2 away from the turning point. Okay, but same thing. The turning point is in the middle here at 0. If I add the square root of 2, I get to one x-intercept. If I subtract the square root of 2, I get to the other intercept. So how does that compare with my little formula here? Well, this negative b over 2a is the midpoint between the two x-intercepts. And so negative b over 2a is where the turning point happens. This is always going to be the x-coordinate of the turning point, or the vertex. Okay, that negative b over 2a part right there. And that's going to allow me to find the turning point even when we actually don't have any x-intercepts. If this part over here, for some reason or other, we had a negative under this radical, and so it wasn't giving us any real solutions, that would mean our parabola did not cross the x-axis. Turns out we can still find the x-coordinate of the turning point, or the vertex, by using negative b over 2a. So this is a very important formula. It's another formula that you want to remember. Okay, it's just kind of the first little part of the quadratic formula, and it's going to be a big help to us when we're trying to find that maximum or minimum of our quadratic function.